Next up at noon here, we have Tamas Rudnai talking about the journey of an Apple II emulator, creating a new emulator for the Apple II. Are you available to speak, Tamas?
Hi, KFest. It's Tamas Rudnai speaking from California. And today I'm going to talk about Steve 2, a brand new emulator. I'm going to talk about why did I do that and how did I do that. So let's get to it. I'd like to dedicate this talk to my father. He was a mechanical engineer, a plumbing engineer, designing water supply system and heating system for large buildings. And he was a dedicated man. He learned AppleSoft Basic to be able to write software for himself to ease his work. Part of his job was budget calculations, which means you have to estimate the money you need to realize a project. So for that you need to go through on all the drawings and calculate every single components you need, like how many miles of pipes you need and how many screws you need and different components you need for the project. And it was a tedious job. You needed 3 or 4 engineers to work on this for 3 weeks. 3 weeks. And he was able to do this on the Apple II computer just in 3 days. 2 years ago he passed away, and I traveled back to Hungary for the funeral. And when I went down to the basement, look what I found. I found the old Apple II computer he was using. So this was a Taiwanese clone we had to smuggle into Hungary. Hungary was part of the Eastern Bloc countries, so we were not allowed to buy any Western computers or Western any devices. So we had to have some friends to be able to bring this motherboard and all the components from Western Germany. That's why you can see the keyboard is German. My father was using this computer for his job, as I mentioned, and sometimes it took a long time to finish his calculations. So I remember that he came to the kitchen for a very good lunch, takes 1.5 hours, to eat everything and then have a nice coffee and talk to the family and everything, and then he went back and it was still working. As far as I know, sometimes it took like 3, maybe 4 hours to do all the calculations. So that led me thinking how long that would take to run that software on a modern computer. Actually, not a modern computer. I wanted to know how long would that take if this Apple II computer would be built using modern technology. The 6502 would be much faster, and we had hard drives or SSD drives instead of floppy drives. So many people are asking me, why do you want to create your own emulator? And you know what, this is a very valid point. There are thousands of emulators out there, and I could just load my own software on it and measure the speed. And every time they are asking this question, this is my answer to it, that I just want to have fun. But it's not only about having fun. There are many other aspects of a project like that. For example, you have the benefit of controlling speed, rendering techniques. And of course, you learn a lot of things. You learn about Apple II hardware. You learn about how AppleSoft Basic works, in a deep level. You learn about 6502 in a deeper level than before. And also maybe about the host computer, and hopefully you can explore something new that hasn't been explored before, like inventing some new techniques, emulation techniques. And sharing is caring, so I really believe that information needs to be shared with the peers and of course next generation. Before we go any further on this journey, we'd like to know how long does it take to run this simple program. It just counts from 1 to FFFF and prints the results out of the screen. And on the original Apple II, it takes almost half an hour. This is a significant amount of time. So we have to fast forward this video. You can see the stopwatch on the top of the screen, and you can see that it's going crazy right now, and it's almost over. So you can see that, yeah, it's 31 minutes and it's still counting, and it's almost done. Just a couple of more, still running, and it's done. So yeah, it takes a lot of time. I just wanted to measure in the early stage how fast my emulator is, so I injected this very simple program into the memory, address 0, and it does nothing else, nothing fancy, just jumps back address 0, so it executes itself again and again and again, same as this puppy. And as you can see, even if you are catching your tail, it's not very useful, except you can see how fast it's going to happen. So there's the number I came up with. The first number is the MIPS, mega instructions per second, so how many millions of instructions executed in 1 second. This number is also known as meaningless indicator of processor speed, because we don't really know how fast it is, you know. But the second number is maybe more relevant to us, because we know that the original Apple II is running at 1 megahertz, and compared to this one, it's almost 1 gigahertz. So I think this was a significant speed increase. So the next obvious thing to do was to emulate something meaningful, and for that I injected something else into the memory, and that was the Apple II ROM. I obviously injected the Apple II ROM into the appropriate memory space, and also made some 6502 initialization in order to be able to run the ROM. And the result is, wow, what just happened? If you want to know why am I so excited, just take a look at these guys. It's printing out Apple logo, and it's doing it in backwards. The only question we have left is, how are we going to display this logo on the screen? In order to be able to display the character on the screen, we need to pick up the character from the text memory and push that character into the character translator, which is a very simple routine. You know, it just picks up the Apple II ASCII code and translates into Unicode, and then we can build up a string from these characters and display it on the screen using a special font set. And finally, we've got the Apple logo on the screen. So this is really like a turning point, because we know we can create our own emulator. And the emulator started to grow from here. I had to work on the graphics simulation, and graphics simulation is a big deal for me, because this was one of the reasons I fell in love with computers, the graphics, right? And of course, you had to work on the disk emulator, because without disk emulation, you got nothing. You only can type some commands into the Apple and nothing else. You cannot load any programs and play games and etc. So this had to be done. And of course, after I've finished disk emulation, I've got those loaded from the disk. So I could get the catalog and load the software from it. I was so happy. And of course, I could play my favorite games on my emulator. Hard Hat Mac, you know, one of my favorite, and one and only Qbert. Before we talk about speed of Steve 2, I'd like to make a disclaimer. I was comparing Steve 2 with other products. Of course, you know, I wanted to know how well it's doing, and I really like those emulators I'm going to compare with. I really appreciate the efforts people put on those projects. So for that, I'm not going to tell you the names, and please don't even ask, not even personal emails, because this is not a war. It doesn't really matter, you know, which products I'm talking about. Alright, so I'm going to create a comparison chart without telling you the names of these emulators. Emulator 1 is very popular and it's a high quality product and I really like it. It was able to make 34 megahertz on my computer, which is really good, 34 times higher than the original Apple II computer. And Emulator 2 was a little bit faster. It's 120 megahertz, right? So it's 120 times faster than the original Apple II, which is brilliant. I mean, come on. So when I checked the speed, I was expecting to have some degradation, and I was right. It showed 352 megahertz, which is very good. I mean, it's 2 times faster than the competitor. So I was happy. However, I was thinking, why did the speed degraded that much? So I was tweaking the code until I got 482 megahertz. And this was just a little reorganization. How do we access to the memory from different instructions? But can we go higher? And the answer is yes, of course we can. With a little more tweaking with the code, I was able to do 521 megahertz. So this was the point when I thought, okay, no more, that's it, I'm happy. But then in the middle of the night, I woke up, started to walk up and down, thinking about this, and I had new ideas. I realized not all instruction needs to be accessed to the memory in the same way. And I was able to make 721 megahertz with that technique. And if you thought it's over, sorry, it's not. I was thinking further, how do I do the memory management? Completely rewritten the way memory pages and memory access handled. And I was able to go up to 900 megahertz. And of course, I didn't stop with that. I started to work a little bit more and more on the technique. And finally, I got to 1.3 gigahertz. This speed is so high that everything is affecting the results. So if you're recording the screen or running some apps on the background, it's affecting the speed. And also how you are compiling the code. Because how the host computer CPU works is that you have several levels of caches and branch predictions and loads of other techniques in modern computers. And if you are outside, memory access is outside of this cache, then you are out of luck. You are degrading the speed a lot. So in one compilation I was able to reach the 1.3 gigahertz, and the other compilation it went down by 200 megahertz, so it was only 1.1 gigahertz. Put the speed into retrospective. Do you still remember my original code I was using to test the speed? Yes, here we go. And just a reminder, on the original speed it took 31 minutes to run. So let's crank up the emulator all the way up, and because I'm recording the screen, it won't go up to 1.3 gigahertz, it's only 1.2 something. Anyway, so let's run it, and that's it. That was it. The 31-minute run, it only takes 2 seconds on the emulator. Let's just calculate how long that would take to run that software my father was using. That software was running 3 to 4 hours each time. So we are going to count as 4 hours, and this is how many minutes, this is how many seconds. And if you want to know how long does it take to run on Steve 2, we just have to divide it by the speed increase. And it's going to be 11 seconds. So my father would be really happy with these results. Alright, enough talking. Let's do some action. So let's power it on. And you can hear the disk activity. It's because the disk sound emulation is on. You can turn it off if you want, but usually I leave it on just to hear that we are doing something with the disk, like catalog. We also have a quick disk mode. Quick disk mode is great when you want to load something quicker than before. So right now it's off, and if we are loading renumber, then you will see it takes a couple of seconds to load that program. Yes, and now we can see that the renumber program is in the memory. But if we turn this quick disk mode on, clear everything, so it's no longer in the memory, right? And we get the catalog. It's really fast, right? And if we are loading renumber, 3, 2, 1, go. So it's a fraction of a second. Alright, and also if we reload DOS, it's less than a second, and it's loading DOS 3.3 and integer basic. So you can actually see that integer basic is loaded. Alright, let's see what we've got on the toolbar. We've got a speed selector, so you can select what speed do you want to use the emulator with. You've got the monitor selector, so you can turn on CRT mode, which is scan lines plus some other rendering techniques to look like as a CRT monitor. And you can use green phosphor or amber or white mono monitor. We just leave it in a color mode right now. And of course a volume button in here. And on the left hand side we've got the CPU mode selector. I'm going to talk about it later. And the game input selector and copy and paste functions. And that's it. I think that's the main function. Oh, on the bottom of the screen you will see a real speed indicator, so it's really measuring the actual megahertz. You can see that right now it looks like it's just following the same number, but actually it's really measuring the actual speed of the CPU. Alright, it's time to play Donkey Kong, all-time favorite. So load the disk and make sure that the quick disk mode is on, because we don't want to wait for the disk. And now we just need to power on. And as you can see, it loads really fast, less than a second. And I turn on CRT mode because it looks better in my opinion. So now we can just stop playing. But it's too loud, so you will be hear me better if it's not that loud, right? Alright, so you can play Donkey Kong or any games in normal mode as well, but if you turn on game mode, the screen refresh rate cranks up to 60 Hz, 60 frames per second. And also the input lag is going down from 33 milliseconds to 1.5 millisecond. So it's much better in my opinion for games. And oh, I didn't expect that one. Alright, anyway, Donkey Kong is great. I'm not. And we have heart attack. Yeah, we can start playing. Too loud. So yeah, heart attack is really great with keyboard. I think better than with joystick. So I'm just playing with the keyboard. Hopla. And I'm still not good at it. All right. Okay. Let's play the game. Pedal is on, and start the game. So you can see that the little ship is following the mouse cursor. Is because I'm assigning the mouse cursor into certain mouse joystick position, and the Wave Navy is almost one-to-one assigning the joystick position to the ship position, and we can actually exploit this behavior in our game. Just kind of cheating, but anyway, so I put the mouse cursor on top of the helicopter and just keep shooting. So it's really easy to defeat the enemy this way. I wanted to show the eco mode. So what is eco mode? To understand what is eco mode, I'm going to load Merlin assembler. Let's do the quick disk mode and power it on. So as you can see, Merlin works, perfectly in normal mode. And if I take a look at the activity monitor, not this one, but in here, actually this guy. So this is Steve 2. If we take a look at how much CPU cycle it takes from the host computer, it's around 4%, which is not that bad, right? But if I turn on the eco mode, then it goes down to 0.5% and goes down for good. That's because Steve 2 recognizes that the software is waiting only for keyboard input, and until we are not pressing any button, Steve 2 is in pause mode actually. So if I press a button and go back here, we can see that CPU cycle goes up a little bit and then goes back again because it's waiting for keyboard input again. Press another keyboard and we can see the activity. So this is really cool, especially when we are using Merlin. To show you what it means, I'm going to load macro library, and we can see that we have a software. Let's just speed it up. It's 300 lines of source code, and if we are going to do a compilation, it takes quite a while to compile this code, right? So normally what would you do is to go here and then crank up the CPU speed manually until the compilation finished. But in eco mode, you don't have to do that. So we are eco mode, we are cranking up the speed up to max, and we can still see that it doesn't take much CPU cycle from the host computer. But if I say compile, no, and number 3, maybe, bing, it's finished. So it's really fast. So the advantage is that you can use the speed of the emulator while you can still save the battery on your laptop. So for example, if you are working on an airplane or go to McDonald's to work on your project, you can still do it. So that's eco mode. If I turn back normal mode again, guess what? It's 100%. Alright. Oh, you're still here. That's great, because I have some good news for you. In the last couple of months, many people were asking me how can they test Steve 2 out, and when is it going to be available, how much does it cost. And today I'm going to announce that Steve 2 is going to be available for free. No cost at all, no dollars, it's just free. And it's going to be open source. So you can download it, you can compile it for yourself, you can play with the code, you can modify it if you want. It's under GPL free. And I really hope that some of you guys will enjoy Steve 2 as much as I do. So I really hope that you are joining to Steve 2 team and make it even better. So just follow the link, and I will make this link available on KansasFest forum and also on Facebook. So bear with me and please let me know what you think. Thanks for watching. Before you go away, I'd like to thank to these guys. You may know Peter from Total Replay. He was a dear colleague of mine and sitting just a couple of desks away from me. And thanks, Peter, for helping me understand how disk works. David, you may know him because of Booty device. And thanks, David, to help understanding how the speaker works. Also Kostin. Kostin is my colleague and a dear friend. Thanks, Kostin, for helping me on understanding emulation technologies. And also I'd like to say thank you to Arpad Darvas. He's a very good friend of mine. He had great ideas about how to improve the emulator. Dumitru, you're awesome. You helped me a lot. And Mario, thanks for letting me know, how your Commodore emulator works. It helped me a lot as well to understand. And of course, the entire Apple II enthusiasts group on Facebook. You guys are awesome. And last but not least, thanks KansasFest. Great stuff.
All right, we have about 5 minutes left. Any questions from the audience?
Am I supposed to read the questions, or you guys are going to do that?
Looking for them so I can read them to you. What were the main techniques you used to achieve such great performance?
All right, so I thought about how memory management works. So normally, in order to be able to emulate the Apple II entirely, you need to use a paging technique. So it means that you have different memory pages, and then you are assigning memory pages into different memory locations. Basically, you are emulating MMU chip entirely, and I thought that instead of that, you can just copy the appropriate memory location into one piece of array in the memory, and then just use that one. So that was the main thought, that you don't need to do the page translation on the fly. You are just doing when you are doing the page switching. So that was one of the main functions. But there are loads of other minor techniques, like which instruction is using, what kind of memory access, and it's a lot of things. I can make a video about the technical details later on, and I can publish it.
Somebody wants to know if there's any support for hard drive images or hard drives.
Not yet. I'm planning to do that because I wanted to run Total Replay on it, but I haven't done yet. So.
And is this is just this is just the Apple II, not 2 Plus, 2E, or 2C, right?
There are some work to go towards Apple IIe. It hasn't been fully implemented yet. At some extent, yes, but because the extended memory is already implemented, but there are some issues right now. So if you are loading a newer version of Merlin, then you would have some issues. But yeah, for example, the 80 column display is implemented, and these kind of things. So, and the extended memory, and
And about the 2 Plus, it would work as a 2 Plus?
I think so. Yes.
Okay. Jack Nutting was wanting to know, where did you find the source code?
Source code I've written entirely from scratch. So from I started with the 6582 CPU emulation, as I mentioned in the video, and I just started to write it from scratch, like every single bit.
Serial port support?
Not yet. I had some requests about it, so probably I will work on it. There are loads of hardware components which are not yet implemented, so yeah, I have a huge schedule in front of me.
Yes, I suppose once you get done writing the emulator, then you have to write code to emulate a card and another card and another card to get it all to work.
That's correct. Yes.
Looks like that's everything. Thank you so much for this great presentation.
Thank you.